In this video, we'll take a look at a few more identities. Part C, we have a cosine theta to the fourth minus a sine theta to the fourth divided by a cosine squared equals 1 minus tangent squared theta. So as we look a little closer to this, it might be helpful here to start with the left side and see if we can transition that to look like the right. So I'm going to start with this left side, and then we'll consider what it's going to look like if we do some factoring techniques and possibly doing some cancellations. So let's consider first looking at the cosine to the fourth minus sine to the fourth. This might take a little bit of kind of reaching back into our algebra toolkit to see that this numerator here is really a difference of squares. So let's consider this as a difference of squares where we have cosine squared theta, quantity squared, minus sine squared theta, quantity squared. So there's really a difference of squares there, where the first item in our difference of squares is cosine squared, and then we have a sine squared in the second position. If we recall just how difference of squares work from the past, if we had any value a squared minus b squared, we know that these are going to factor as a pair of a minus b and a plus b. So we can do the same algebra here, just replacing that a and b component with a cosine squared and a sine squared. So let's consider rewriting this left side to start. We have the difference of squares here will become cosine squared theta minus sine squared theta, and we'll multiply this with cosine squared theta plus sine squared theta. So that'll be my difference of squares kind of factored out there in the numerator, and this will be all over a cosine squared theta. Again, I'm not going to touch the right side of this equation yet. I just want to make sure that I can rewrite this left side as 1 minus tangent squared. We'll notice that in the numerator we can utilize one more property, which is the Pythagorean theorem operation. So the Pythagorean theorem, we know this cosine squared plus sine squared, this all is equal to 1. We can just say that's a multiple of 1. And then we'll be left with the difference of squares again on the left side. But here, notice that we have a cosine squared and a cosine squared. We can actually go and divide each of those two terms by cosine squared. So if I divide that first term, that will be just 1. Cosine squared divided by cosine squared is 1. And then minus, if I divide the sine squared, well, sine squared, we can write this in a couple ways. Sine squared theta over cosine squared theta. This is simply going to be tangent squared theta. And so this gives us exactly what we wanted from the beginning. We wanted to find this to be 1 minus tangent squared. And so that's exactly right. And we will be done with that proof. So we used a difference of square technique, working with some factoring, and then the Pythagorean theorem identity was handy here. Let's take a look at one more of these. Part D, we have 1 plus cosine theta is equal to sine squared theta divided by 1 minus cosine theta. All right, so again, I'm going to consider manipulating the right side of this equation first and seeing if we can get anything useful in our calculation. All right, so one thing that we can do in this situation is to get in terms of only sine or cosine. I know my solution is in terms of cosine, so that gives me a clue of kind of what I want to transition as. If I can get this right side all in terms of cosine theta, that would be actually a pretty good thing. So let's see if we can do that. The only way I know to get this sine squared theta in terms of cosine is using that Pythagorean theorem again. So I'm going to use the Pythagorean theorem to work with sine squared theta. I know 1 is equal to cosine squared plus sine squared. And so sine squared itself is going to have to be 1 minus cosine squared theta, just by doing a subtraction there. This is all over 1 minus cosine theta. And again, in this case, we can use a difference of square technique. Notice that we could rewrite 1 as 1 squared here. And so we do have a difference of squares in the numerator. So let's rewrite those. This would say this is the same as 1 minus cosine theta and 1 plus cosine theta divided by 1 minus cosine theta. And last but not least, we can see the cancellation we can make here with division. 1 minus cosine theta, 1 minus cosine theta go away to 1. And I'll be left with just a 1 plus cosine theta. And that's exactly what we wanted to solve for. So again, our work to prove this is really what we're looking for. We know the solution, we just want to verify that solution on the left side. So a couple techniques that we used with this section were working with the Pythagorean theorem, using the difference of square technique for factoring, and then working with sines and cosines when we can. So if we have any reciprocal functions or tangent functions, if we can rewrite those in terms of sine and cosine, that usually is going to be a helpful technique when proving identities. So hope this video is helpful with this lesson. Hope to see you in the next video where we'll talk a little bit about sum and difference identities and the half angle and double angle. Thanks for watching.